Hello and welcome. In this video, I want to teach you some useful rapid arithmetic techniques, and I would like to start by multiplying into 11. For instance, let's multiply 45 into 11. To do that, we write down 4 here and 5 there. Then we add 5 to its left digit, which is 4. So 4 plus 5 equals to 9, and we write it down here, and that's it, we're done. The answer is 495. Let's have another one. Let's multiply this crazy number into 11. Again, we write down the most left digit, which is 6 here, and the ones place, 7 there. Then we add 7 to its left digit, which is 2. 7 plus 2 is 9. We write it down here. Then we add 2 to its left digit, which is 5. And the answer would be 7. We write it down next to 9. Then 5 to its left digit. The answer is 5 plus 3 is 8. We write it down next to 7. And 3 to its left digit, which is 3 plus 6 is 9. And we write it down here, and this is the answer. You might be thinking that why multiplying in this way works. Don't worry about it for now. I will prove it to you. Also, I will prove the techniques I give you here at the end of this video. But for now, you just enjoy the methods. And if you do not trust my answers, you could just use a calculator, which would give you the same answers. In the two examples so far, the sum of every digit to its left one was smaller than 10. But what if it is greater than 10? Like here, the sum of 9 and 4 equals to 13 and is greater than 10. So here, what we should do is writing down 9 here and not 4. Then add 9 to 4, its left digit, which is 13, and write down its ones place, which is 3. Then increase 4 as 1. So 4 plus 1 would be 5. We write it down here and we're done. This is the answer. Okay, here's my next technique, which is squaring any number of 9s, like this. So let's square the number of 4 9s. Let's see how we could do it fast. Here, first we count the number of digits. Here we got 4 digits. Okay, now we decrease it as 1. So 4 minus 1 equals to 3, and we write down 3 9s here. Then we write down an 8, then 3 zeros, and finally a 1, and we're done. This is the answer. That's simple. Simple and fast. Let's have another one. Let's square the number of 5 9s. So again, we count the number of digits. We got 5 of them, so we decrease it as 1, which would be 5 minus 1 equals to 4. So we write down 4 9s here, and as before, an 8, then 4 zeros, and finally a 1. That's it. That was very simple and fast. Okay, let's go to our next technique, which is multiplying two numbers ending in 5. Like these. Let's multiply 25 into 45. Here, we first multiply 5 into 5, which is 25. And we write it down here. Now, we take the numbers preceding the 5s, which here are 2 and 4, and we multiply them into each other. So, 4 times 2. Then, we add the answer to their average or mean. And what is the average of 2 and 4? It is 2 plus 4 divided by 2. 2 plus 4 equals to 6, divided by 2 equals to 3. So, what is 4 times 2 plus 3? It is 8 plus 3 or 11. And we write down 11 next to 25, and that's it, we're done. So, our next example is a bit harder. Here again, we first multiply 5 into 5, which is 25. And we take the numbers preceding the 5s, which here are 22 and 10. We multiply them into each other, and we add the answer to their average. What is their average? It is 22 plus 10 divided by 2. 22 plus 10 equals to 32, divided by 2 would be 16. Okay, now let's calculate this. This is 220 plus 16, which is 236. And we write it down next to 25 and we're done. This is the answer. Here's another one. Again, we multiply 5 into itself, which is 25. We write it down here. And the preceding numbers are 34 and 11. So we multiply them into each other, and it is multiplying into 11. So that would be, we write down 3 and 4, and we add 4 to 3. So that would be 374. And we add it to their mean, or their average. What is their average? The average of 34 and 11, it is 34 plus 11 divided by 2. And that is 45 divided by 2, which is not an integer. So what should we do? Here, instead of dividing 45 by 2, we divide 44 by 2. Okay? And that would be 22 plus 374 would be 396. But we also change the 25 to 75. And we write down 396 next to 75 and we're done. So, for the cases when the numbers, the average of the numbers preceding 5s be not an integer, that would be our technique. Okay, now let's see how to square the numbers ending in 5. So for instance, what is the square of 75? As you know, the square of 75 equals to 75 times 75. So it is the multiplication of two numbers ending in 5. As before, 5 times 5 is 25. We write it down here. And we multiply the preceding numbers into each other. Here are 7 and 7. And we add it to their average. And the average of any number and itself is itself. Okay, 7 plus 7 divided by 2 would be 7 again. Now, here, inside parentheses, it is 7 sevens. 7 times 7 means 7 sevens. And outside of it, we got plus 1 7, or plus a 7. Now, here we got 7 sevens plus 1 7, and that would be 8 sevens. Just like 7 apples plus 1 apple would be 8 apples. So 8 sevens means 8 times 7. And that would be 56. And we write down next to 25. And we're done. So to square the numbers ending in 5, we write down 25 and we multiply the number preceding 5 into its next integer. For instance, here we multiplied 7 into 8 and we wrote down the answer next to 25. Okay. Let's have another one. What is 95 squared? As before, we write down 25 and we multiply 9 into its next integer, which is 10. So the answer would be 9025 or 9025. Okay. It's a bit harder example. Again, here we first write down 25, then we multiply the preceding number into its next integer, which means 44 times 45. But how to do that fast? 44 equals to 11 times 4. 4 times 45 equals to 180. You could think of it as an angle of 180 degrees, which consists of 2 right angles, and each consists of 2 angles of 45 degrees. Okay? Now, what we should do is only multiplying 11 into 180. And we could do it fast. And to do it fast, we first write down 1 and 0. Then we add 0 to 8 and write it down here. Then 8 by 1, which would be 9. And this would be our answer. And this is awesome, you know, because this is a tough number to square, but we just squared it in a fast way. Okay, let's go to our next technique, which is for when the most left digits of our two numbers are the same. Let's start by a simple example. So here we first multiply 7 into 2 and we carry the 1 of 14 to the next step, and in the next step we multiply 8, which is the common digit, into the sum of the remaining numbers, which are here 7 and 2, and that would be 72, and we added to 1 we carried in the first step, so that would be 73, and again we carry 7, the tens place of 73, and we multiply 8 into itself. 8 is our common digit, so that would be 64, and we added 2, 7 we carried in the previous step, so that would be 71. So the answer would be 71, and we write down the ones place of 73 of the second step next to 71, and finally we write down the 4, the ones place of the first step. This is our answer. Let's have another one. Now here, of course, their most left digits are the same, but they both got 25 in them. But first, let's have a simpler example. Let's multiply 64 into 67. So again, we multiply the ones places into each other. So 4 times 7 would be 28, and we carry 2. Then we multiply the common digit into their sum. 4 plus 7, that would be 66. Plus 2, we carried before, that would be 68. Again, we carry 6, the tens place of it. And finally, we multiply their common digit into itself. So that would be 36 plus 6, we carried in the previous step, that would be 42. So we write down 42, next to it 8 above the ones place of the second step, and next to it the ones place of the first step. So this is our answer. Now let's get back to our previous example. Again, here we multiply the ones places into each other, and we carry its tens place, which is 2, and in the next step we multiply our common number into their sum, and this is easy because it is multiplying into 11. So we write down 2 and 5 at the ends, and we add 5 to 2. Okay, plus 2 we carried in the previous step would be 277, and here we carry 27. You know, the number preceding the ones place. And the last step would be multiplying the common number into itself. And this is easy if you do not already know the answer. It is squaring a number ending in 5. So we write down 25, and we multiply 2 into its next integer, which is 3. That would be 6. Plus 27 we carried in the previous step. Okay, that would be 6, 5, 2. And now we add first the ones place of the second step, which is 7, and then the ones place of the first step, which is 4. And this is our answer. It would be more interesting if the sum of the ones places of the numbers we'd like to multiply is equal to 10. For instance, let's suppose in the last example, instead of 8, we have 7. 7 plus 3 equals to 10, and they both got 25. So here in the first step, we got 3 times 7, which is equal to 21. And in the second step, instead of adding 3 and 8, we got 3 plus 7, which is equal to 10, and that would be 250. Plus 2 we carried before, we carried in the first step, would be equal to 252. And here we carry 25 instead of 27, as in the last example. Now, in the next step, or the last step, we have to multiply 25 into itself, but then we should add it to 25 instead of 27. So 625 plus 25 would be 650. And we write it down here, and we write down 2 and 1 above in front of it. So this is our answer, but 650 or 625 plus 25 equals to, what is 625? It is 25 times 25, plus another 25 would be 26 times 25, okay? So here's the rule. In such cases, we multiply the common digit into its next integer, we write it down, then we multiply the ones places into each other, and we write it down in front of, for instance here, 650. As you see here, instead of doing this way, we could have just multiplied 25 into its next integer, 26, and that would be equal to 650, and multiply 3 into 7, which is 21, and write it in front of 650. Okay, let's have another example. Here we got 7 as our common digit, and 6 and 4 whose sum equals to 10. Okay, so according to the rule, the product would be equal to, we first multiply 6 into 4, which is 24, then we multiply 7 into its next integer, which is 8, which would be 56, and we write down 24 in front of it, and that would be our answer. So here's a harder one. Here, the sum of 8 and 2 equals to 10, and 453 is our common number on the left of the two numbers. Okay, so here we first multiply 8 into 2, which is 16, then our common number into its next integer, which is 454. But how to multiply these two? Here we got 45 in both of them, so we first multiply 3 into 4, that would be 12, we carry 1, then we multiply 45 into their sum, which is 7, and we add it to 1, that would be 316, and we carry 31, and finally we multiply 45 into itself, which is equal to, which is just squaring a number ending in 5. And first we write down 25, then we multiply 4 into its next integer 5, so that would be 25, and we add 31 to it, so that would be 56, and we add 6 and 2, we write down 6 and 2 above in front of it, and this would be 453 times 454. So the next step would be adding 16 in front of it, or write it down in front of it. So this would be our final answer, and we did it without any calculator or without the crazy multiplication you learned in the elementary school. Okay, I hope you have a good time so far. So let's go to our next method. What if the most left digit of our two numbers are the same, and the sum of the remaining numbers equal to 100? Like this. Here, the most left digit of both equals to 7, and the sum of 89 and 11 equals to 100. So here, we first multiply. You see here, 7 is actually 700, okay, because it is in the hundreds place. So the first step is multiplying 700 into 700 plus 100, which is 800. So this would be 56 and 4 zeros, And the next step is multiplying the remaining numbers into each other, which here are 89 and 11. Again, it is multiplying into 11. The sum of 9 and 8 is greater than 10. So we first write down 9 and then add 9 to 8, which would be 17. And we write down 7 and we increase 8 as 1. So that would be 979. Okay. And the last step would be adding these two answers. And this is our final answer. So let's have another one. Here, the most left digits are equal and equal to 9. And the sum of 35 and 65 equals to 100. So again, we should multiply 900 into 900 plus 100, which is 1000. That would be this. Also multiply 35 into 65, which you know it, because it is multiplying two numbers ending in 5. So that would be, first we write down 25 and multiply 3 into 6 plus their average. And their average is not an integer, so 3 plus 6 would be 9. And instead of dividing it by 2, we divide 8 by 2. And instead of 25, we write down 75. So that would be 2275. And we add the two answers. And we're done. This is our final answer. Our next method is for when the ones places of our numbers be the same as here. So here's the method. We first multiply 3 into 3, which is 9. Then we add the remaining numbers to each other and multiply the result into 3. So that would be 195. We carry 19. And the last step is multiplying the remaining numbers into each other and adding it to 19 we carried before. So this would be 919. And we add the ones places of the previous steps in front of it, and that's it. This is our answer. So let's have another one. What if the tens places of our numbers, the sum of them be equal to 10, like here? Here again, first we multiply 7 into 7, then we multiply remaining numbers into each other and add it to 7. That would be equal to 31, and we write down 49 in front of it, and that would be our answer. Let's have another example in which the ones places are the same and the sum of the tens places equals to 10. So we multiply 9 into 9, we multiply 2 into 8 and add it to 9. That would be 25, and we write down 81 in front of it, and that's it. Okay, let's have some examples or some techniques for division, for fast division. And here I'd like to start by dividing by 5, like here. So it is a fraction, and we could multiply the numerator and the denominator of any fraction into the same number. Here we multiply into 2. So the denominator would be equal to 10. And we just turned division by 5 into division by 10, which is way easier. And to do that, we just need to double the numerator or calculate the value of 342 times 2, which is easy, which is 684. And to divide it by 10, we just put a decimal point before the first digit. It's easy. Okay. Here's another one. So we have learned the method, and what we need to do is double the numerator, which would be this, and put a decimal point before 6. Now, let's go to division by 25. Here, again, it is a fraction, and instead of multiplying the numerator and the denominator into 2, we multiply into 4. So the denominator would be equal to 100. And we just turned division by 25 into division by 100, which is way easier, and all we need to do is multiplying the denominator into 4, and that would be 884, and to divide it by 100, we just put the decimal point before the second digit. Okay, here's another example, and it is dividing by 125. And here we multiply the numerator and the denominator into 8. And 8 times the denominator would be 1000. So we turn dividing by 125 to dividing by 1000, which is way easier again. Denominator times 8 would be equal to this, 9608. And to divide it by 1000, we just put the decimal point before the third digit. Okay, but how to multiply into 5? To do that, you see, 5 equals to 10 divided by 2. Okay, and as this is a product, we could divide 248 by 2 instead of dividing 10 by 2. So all we need to do is dividing 248 by 2, which would be 124 or 124, then put a 0 in front of it. Okay, let's have another one. Here we have learned the method, so we just divide 2488 by 2, which would be 1244, then put a 0 in front of it. Now, how to multiply into 25? Again, we could write 25 as 100 divided by 4. And you could do that. Okay. I'm not gonna do it, but you could do that as a practice. Now, to multiply into some numbers, for instance, like 21, we could write it as 20 plus 1. And according to distributive property of numbers, we could write it as, or we could first multiply 45 into 20 and add it to 45 into 1, which is equal to 45. So 45 into 20 equals to 900 plus 45 would be 945. Let's have another one. Here we could write 19 as what? As 20 minus 1. Again, according to the distributive property of numbers, we could first multiply 72 into 20 minus 72 into 1. Okay, 72 into 20 would be equal to 1440 minus 72 would be this. Okay, let's have another example. Here, again, we could write 101 as 100 plus 1. We could do it as a practice. Or here, we could write 999, the 4 nines, as 10,000 minus 1. And then use the distributive property. You could do it as a practice. I'm not going to do it here. So our next technique is squaring numbers using the complete square identities, these two. So let's calculate 26 squared. Here 26 equals to what? Equals to 25 plus 1. So we could use the first identity above, in which a equals to 25 and b equals to 1. So that would be equal to this according to the identity. And all we need to do is calculate the sum, which is easy. But what about 94 squared? 94 equals to 95 minus 1. So we could use the second identity, in which a equals to 95 and b equals to 1. What is 95 squared? You know that already. All we need to do is write down 25 and then multiply 9 into x, next integer 10, and write it down before 25. So this is the answer. Now let's have our next method. You see, if you want to multiply this using the method you learned in the elementary school, you should first multiply 4 into the upper number into its every digit, then multiply 2 into its every digit. And this is, time wasting, but we could multiply 24, the whole 24, into the digits of the upper number. So let's do that. 24 times 5 would be 120, and we carry 12. Then we multiply 24 into 6 and add it to 12, which would be this. We carry 15. Then multiply 24 into 2 and add it to 15, which would be 63. We carry 6. And finally multiply 24 into 3 plus 6 would be 78. So we write down 78, and in front of it we write the ones places of each step. Okay, and that would be our answer. Okay, let's go to our next technique. How to calculate this product. It doesn't look like the previous examples, but here we use a rule which says the product of any two numbers equals to the square of their average minus the square of half of their difference. And we use, mathematically it looks like this. So let's first calculate their average. Their average would be equal to their sum divided by 2. Their sum equals to 200 divided by 2 is 100. And half of their difference would be equal to 12 divided by 2, which is 6. So all we need to do is calculate this. And 100 squared equals to 1000, equals to 10,000, minus 36. So this is our answer. Okay, Now I'm gonna give you proofs to some of the methods. But before that, for more free videos, please go to my YouTube channel, on which I teach mathematics in a different way. Let's go to the proofs. As I said before, to multiply into 11, we first write down 2 and 4. Then we add 2 to its left digit 5, 7. Then we add 5 to its left digit 4, 9. Okay, that was the method. But why? Here, to prove it, we could write 11 as 10 plus 1. And according to the distributive property, we could multiply 452 into 10 and add it to 452 into 1. And the left parenthesis would be equal to this, 4520, and the right one to this. Now, let's add it vertically. Okay, like this. Now, here, what actually happens is that the 452 has shifted to the left as one digit. So every digit of 452 is written above its left digit, as you see. And to add the two numbers, we should add every digit to its left one. Right? Okay? Now let's prove this one, squaring the number of 9s. And to do that, we use this identity in which A equals to 10,000 and B equals to 1. And we write it down as this. We extend it. Okay, 10,000 squared would be 1 with 8 zeros, plus 1 minus 20,000, which would be equal to 7 zeros, and 1 at the end, minus 20,000. And to calculate it, it would be equal to 1 here, 3 zeros. As I said that before, we subtract the number of its digit, we decrease it as 1, so 3 zeros, and then 0 minus 2 would be what? Would be 10 minus 2, or 8, and the other 3 digits would be 9s. That's it. Okay? Now, here, to multiply into 111, we should write it as 100 plus 10 plus 1, and use the distributive property, and that would be equal to this. And as a practice, I want you to find its rule, the rule of multiplying into 111 fast. Okay? Let's go to prove multiplying the numbers ending in 5 into each other. So for instance, here we can write 25 as 20 plus 5 and 45 as 40 plus 5. Now, if we use the distributive property for a couple of times, we could write it as 20 times 40 plus 20 times 5 plus 40 times 5 plus 5 times 5, which is 25. You see, here we multiplied 20 of the first parentheses into 40 and added to 20 times 5, then multiplied 5 of the first parentheses into 40, and finally the 5 into the 5 of the second parentheses. So 20 times 40 would be 800, And again, using the distributive property, we could write the sum of these two as the sum of 20 and 40 times 5 plus the 25. Okay. Now, here, we could write 5 as 10 divided by 2. And as this is a product, we could divide inside the parentheses by 2 instead of dividing 10 by 2. Okay, and this is 10 plus 20. And we could write it as 1 plus 2 times 100. Okay, simple. So far we have 800 plus 300 plus 25. Or 1100 plus 25, which would be 1125. That's what we get using the method I gave you, the fast method, in which we first multiplied 2 into 4, which equals to 8, and add it to their average. Their average is 2 plus 4 divided by 2, which is 3, and that would be 11, and we wrote down 25 in front of it. Now let's prove the method of multiplying the numbers whose most left digits are the same. So, using an example, here again we could write 87 as 80 plus 7 and 82 as 80 plus 2 and use this distributive property a couple of times, makes it equal to this. Again, writing these two as a product using the distributive property makes it equal to 7 plus 2 times 80. And the first parenthesis equals to 6400, and the last one equals to 14. So, and 2 plus 7 times 80 would be 720. So let's add these three vertically. And the three numbers are the numbers we calculated at each step before when I gave you the method, okay? And the sum of these three equals to this, which is writing 71, and then in front of it, the ones places of the numbers we calculated at each step. Okay, hope you enjoyed that, and bye-bye.